Hi guys, today's lesson is on systems of equations. So this is the start of our next chapter, and it all primarily deals with systems of equations. So what are systems of equations? Well, they are two or more equations with the same variables. So two or more equations with the same variables. All right, so the solution to a system we can find either graphically or algebraically, and you're going to learn how to do both. So when you do it graphically, you're going to look for the point xy where the two lines cross each other or intersect. Okay, so that's how we're going to do it graphically. When we do it algebraically, we're going to look for the point xy that makes both equations true, which we'll look at later. So there's a couple types of solutions. So you may have intersecting lines, so two lines that cross, and where they cross is your solution. So when your lines are intersecting, you will have one solution, that point where they cross. So the coordinate xy. So that coordinate is where they cross each other. If you have parallel lines, so a system of equations and the lines are parallel, that means you'll have no solution because those lines will never cross, right? Parallel lines means they never cross. So there would be no solution. If it's the same line, so maybe you have this line as one of your lines and then another line over top of it when you graph it, that would mean they touch each other hundreds of millions of times, right? They would touch each other along this entire thing because those lines would literally be right on top of each other. So you would have an infinite number of solutions, which remember we can write like that sideways looking 8. So those are our three types of solutions. We might have one point, one solution, no solution because they're parallel lines, or an infinite number of solutions because the system is literally the exact same line. So they're lines laying right on top of each other. So today we are going to focus just on graphing systems of equations and solving them that way. So there is a process to doing this. So let's go ahead and write down the steps. So to solve systems by graphing, your first step would be to rewrite the equations in slope-intercept form. So in slope-intercept form, which remember is y equals mx plus b. So that's our first step. We're going to make them look like y equals mx plus b. Our second step would be to use that slope-intercept form and actually graph the line. Once we graph it, we can figure out, do they intersect at one point? Are they parallel or are they the same line? And from there, identify the solution. So again, if they intersect, we would find the coordinate. If they're parallel, we would say there's no solution. And if they're the same line, we would say there's an infinite number of solutions. All right, so let's try the first one together. It says y equals x minus 8 and y equals negative 2x plus 1. So notice these are already in slope-intercept form because it looks like y equals mx plus b. So if we graph this, our slope, remember, is the m. So that's the number in front of the x, which is just a 1, and my b is the number after the x, which is negative 8. So when I graph this, I'm going to start at negative 8 on the y-axis. So count down 1, 2, 3, 4, 5, 6, 7, 8. And from there, I'm going to move my slope, which is up 1 over 1, up 1 over 1. All right, and then once you do that, go ahead and connect the dots. So that's our first one graphed. Our second one is y equals negative 2x plus 1. So again, your slope is the number in front of the x. Your y-intercept is the number after the x. So I always start at my y-intercept. So that means I have to start at 1 on the y-axis. Then I move my slope. So -2 is the same thing as -2 over 1. So this is going to be like going down 2 and right 1 from that point. So down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. And keep going as many as you'd like to go. I could also go up 2, left 1, up 2, left 1, and we'll connect the dots. All right, so we have our 2 lines graphed, and then we look, where did our lines cross? That intersection, that coordinate there, is your solution. So let's find that point. We had to go right 1, 2, 3, and down 1, 2, 3, 4, 5. So I went right 3 and down 5. So my solution, where they intersect, is at 3, -5. All right, go ahead and try number 2 on your own. All right, for number 3, we have 2 equations, -3x plus y equals 8, and -x plus y equals -2. So notice neither of these are in the form y equals mx plus b. So we're going to have to solve first for that. All right, so if we have -3x plus y equals 8. Again, I'm trying to solve it to get this y first. So I need to get that 3x to the other side. So since it's a -3x, I'm going to add 3x to the other side. When I do that, I'm left with the y. And over here on the right side of my equal sign, I have an 8 and a positive 3x. I can't add those together because they're not like terms. So I'm just going to write it 3x plus 8. So now it does look like y equals mx plus b. So my slope would be 3, and my y-intercept would be 8. So now I can graph that one. So I'm going to start at 8 on the y-axis. So count up 1, 2, 3, 4, 5, 6, 7, 8. And then I have to move my slope. So this is like 3 over 1, which would mean to go up 3 and right 1. Well, notice that if I go up 3 and right 1, it will be off my graph. I can also go down 3 and left 1. So I'm going to continue doing that. So down 3, left 1, down 3, left 1. And I'm going to keep going all the way down my graph. It's good to like have the entire graph covered because you're not exactly sure where your lines are going to cross. So that's my first line. Now my second line, it says -x plus y equals -2. So same thing, I need to solve this so it looks like y equals mx plus b. So I need to get that y all by itself. Since I have this -x over here, I'm going to add x to both sides. And I have y equals, I can't really add these together. So when I do -2 plus x, that's the same thing as a positive x and a -2. So now it does look like y equals mx plus b. So when nothing is in front of that x, that's like a 1 there. So my m is going to be 1, and my b is going to be -2. So I'm going to start at -2 on the y-axis and then move my slope. So my slope is 1, which is the same thing as 1 over 1, which means I'm going to go up 1 and right 1. So up 1, right 1, up 1, right 1. And I'll keep going until I get to the top of my graph here. So up 1, right 1. But it also means I could go down 1 and left 1. So down 1, left 1, down 1, left 1, down 1, left 1. And we can see that we just crossed there. So now if we connect our dots, we have just found our solution. So this intersection, that coordinate there is my solution. So let's see. We'd have to go left 1, 2, 3, 4, 5. So left 5 is -5, and down 1, 2, 3, 4, 5, 6, 7, and down 7. So that coordinate is -5, -7. And that is your solution. All right, I actually want you to now try number 5 on your own. All right, let's try number 4 together now. So we have x plus 2y equals 4, and y equals -1/2 x plus 2. So our second equation is already in slope-intercept form. Let's go ahead and graph that. So remember, it's mx plus b. So that means -1/2 is my m, and b is 2. So that means I would start at 2 on the y-axis and move my slope. So since my slope's -1/2, that's like going down 1 and right 2 from that point. So down 1, right 2, down 1, right 2, down 1, right 2. All right. It also means I could do the opposite and go up 1 and left 2. So up 1, whoops, left 2, up 1, left 2. All right, then we'll connect our dots. And we get this line. All right, for our other equation though, we're gonna have to solve that to get the y in front. So we have x plus 2y equals 4. So I need to get this y by itself. So I'm gonna first subtract x from both sides. When I do that, those cancel, so I have 2y equals. Now I can't really combine these, but I have a -x and a 4. So I'm gonna write -x plus 4. I now have to get rid of that 2 in front of that y. So to do that, that's like 2 times y. So I'm gonna divide everything by 2 to make it go away. So I'll have y equals -1/2 x plus 4 divided by 2 is 2. So this is now in slope-intercept form because it looks like y equals mx plus b. All right, so our m, our slope, is -1/2, and our b is 2. So that means when I go to graph this, I'm going to start at 2 on the y-axis, which is right there. And then it wants me to go down 1 and right 2. Down 1, right 2. Down 1, right 2. Look what's happening. It's landing directly on the line we just had. Up 1, left 2. Up 1, left 2. Up 1, left 2. It's the exact same line. Those equations were the exact same. So that means they cross an infinite number of times, right? They're crossing in all these points. So our solution is that we have an infinite number of solutions. So infinity, infinite number, because they're the exact same line. All right, go ahead and try number 6 on your own now. All right, now let's do 7 together. So it says 3x minus 5y equals -35. So I'm going to first solve that to get the y by itself so I can graph it. So I'm going to have to move the 3x to the other side. Since it's positive, I'm going to subtract 3x. I'd be left with a -5y, and then it would make -3x minus 35. My last step would be to divide by this -5, and I have to divide everything by -5. So when I do that, I get y equals -3 divided by -5. If you do that in your calculator, you would hit -3 divided by -5, math, enter, enter, and you should get 3/5. Then -3 divided by -35 divided by -5 is a +7. So now it looks like y equals mx plus b. So I know my m is 3/5, and I know my b is 7. So I'm going to start at 7 on the y-axis. And this would tell me to move up 3 and right 5. 1, 2, 3, right 1, 2, 3, 4, 5. So I'm going to also have to go the opposite direction. So that would be down 3 and left 1, 2, 3, 4, 5. Down 3, 1, 2, 3, 4, 5. All right, so this is our line. Okay, then we have our next equation, which is the 2x plus y equals -6. So same thing, to graph it, I have to solve for y. So I need to subtract this 2x and put it on the other side. You'd be left with y equals -2x minus 6. Well, that one was an easy one. It already looks like y equals mx plus b. So my m is -2 and my b is -6. So remember, this is the same thing as -2 over 1. And the b is where you start on the y-axis. So I'm going to go down 6. Then I move my slope. So negative on top is telling me to move down 2 and right 1. So down 2, right 1. Down 2, right 1. Let's also do the opposite. So the opposite would go up 2, left 1. So up 2, left 1. Up 2, left 1. And we'll keep doing that until we see if our lines cross. And looky there, they crossed. Up 2, left 1. All right, so if we connect our dots, our intersection is our solution. So let's figure out where that is. So that's left 1, 2, 3, 4, 5. So left 5 is -5, and up 1, 2, 3, 4, and +4. So you have a solution at negative, whoopsie daisies, did not mean to do that. You have a solution at, didn't mean to do that either, -5, 4. And that would be your answer. All right, go ahead and try number 8 on your own, and then you are finished. I wanted to see if you remembered, so we did this before break for sure. When you graph x equals -2, remember that this is the x-axis, and you have to find -2, and then I'll leave it up to you. Do you think you're going to draw a vertical line down, or do you think you draw it across? And then you're going to do the same thing for the 3x minus 2y equals -18, just like I did over here. All right, so go ahead and finish up number 8. If you have any questions, feel free to let us know. That concludes your video over systems of equations.